everyone. Welcome to my podcast. My name is Ship Patel. I'm your host. Today we're going to talk about how cool Newton's law of motions are. There are laws explain how everything moves from rockets blasting into space to walking around your room. Let's break them down. Simple way so you can see how they work in everyday life. Newton's first law, the law of inertia. Let's start with Newton's first law, also known as law of inertia. It says that object stays still or keeps moving unless something force them to move or change direction. Imagine you're riding in a car and the driver suddenly hits the brake. Your body your body moves forward right. That's inertia. Your body wants to keep moving. Now think about if an astronaut floats outside the space station and gives himself a little push. They will keep moving in the same direction forward unless they are grabbed on to something. It's because no air, no friction. It's just inertia. Newton's second law, force equals mass times acceleration. Next next up is Newton's second law. This one explains how force, mass, and acceleration are connected. It's written as F equals ma, or force equals mass times accelerations. Here's simple example: pushing a shopping cart. If a cart is empty, it's easier to push it, making it faster. But if it's full of heavy groceries, you have to push a lot harder to get it to move at the same speed. That's because the mass is bigger, so you need more force to accelerate it. In the class, teachers sometimes use fun experiments called Newton's car. You launch a small car with a rubber band and see how it moves when you add weight or push it pull it with the a rubber band harder. It's a great way to see F equals ma in action, aka force force equals mass times acceleration. Newton's third law, action and reaction. Let's let's talk about Newton's third law. For every action there is a equal and opposite reaction. This is one easy to spot once you know what you're looking at. This Think about rockets. When the rocket engine push gas downwards, the rocket gets pushed upwards with the same force. That's how rocket lifts off the ground. Now imagine jump up on a boat. When you push backwards with your feet on the boat moving away and you move forward, it's the same force, just the opposite direction. Cool, right? Let's talk a little about how Newton's first law is used for all car crash tests that every car needs to go through. First law, inertia. When a car suddenly stops, passenger keeps moving forward. That's why seatbelts are necessary. That they apply a force to stop you to prevent serious injuries. Crash test shows how seatbelts and airbags work to protect passengers. Newton's second law, F equals ma, force equals mass plus acceleration times acceleration. The force of a crash depends on the car's mass and speed. Crumble zone observes energy by slowing down, and cars deceleration reduce the force of passenger and safety and improve safety. Newton's third law, action and reaction. When a car crash into something, both the car and the object exert equal and opposite force. Engineers study this design car and redirect the force away from passengers. Car crash tests help apply those laws to save lives, showing physics keeps us safe on the road. So these laws are also super important in space. They explain how rockets launch, how astronauts move, and even how spacecraft stirs in deep space.